Where am I? Hello? Hello? Oh, there we go. Gone for a second there. Hey everybody. Trying to put my mic in the right place. I'm a VTuber. I am a VTuber. You're playing Splatoon? I wish I would play Splatoon right now. I don't have my copy yet. It said it got here on Tuesday, but now it's Saturday. Not sure how that's like works, but like hopefully it shows up because I want to play it. I'd love to play it. Jeez, I'm not gonna read that. Anyway, how's it going, gamers? Hopefully I can stream like a little earlier on weekends, because I normally have nothing to do except for homework, so you know it works out really well. But I had lunch with somebody, so you know I had to like do that. Okay, today we're gonna do something that's a little funky. This is 143. So I should probably put math, but okay, let me crop this because this is kind of annoying. Hope you guys are having a good day. How's it going? Till I tune? So true. Okay, I want to make my OBS like larger. I'd love to like see it more OBS, but it does not want to do that. Kind of annoying of it. I just want to like... The rest of my potential rebrand is in the works. Oh my gosh, that's exciting. Sorry, I just gotta crop this more, but I like can't see it, so that's what's happening right now. How's that look? Oh, there's still a little bit at the bottom. I'm a professional. I'm a math streamer. That's all I care about. I'm gonna learn something. I'm not gonna teach you, I'm gonna learn. Okay. We're gonna Google this on Khan Academy. Let me just get it up first. Can't spell Khan Academy. I guess I should probably put integrals because we're learning an integral thing. Let's see. Yes, here we go. All right. So, where is this? What? Oh. Why is it not working? There we go. All right. Student makes a substitution. This thing equals 3 cotangent of theta in an integral. What are the following equations are true? Well, that's a good question. I'm gonna start at Introduction to Trigonometric Substitution.
This indefinite integral right over here. And you immediately say, hey,
about your Splatoon, are you sure it didn't get delivered to the wrong place? That is a good question. I should ask my parents, but I'm pretty sure they delivered it to the right place. I think so. We have like processing here, because everything goes through basically like, you know, they have to make sure people aren't getting shipped like evil things or whatever. So like, it sometimes takes a bit for stuff to get places, but I should probably check because I've gotten other stuff. Umber ate it? Damn, that would suck. Oh, I should probably... I mean... Okay. Wait a second. Let me switch this real quick. I'm a professional streamer. I can do this so I can actually change things. There we go. There we go, chat. There we go. That looked like I did nothing, but I swear I did something. Okay. We're gonna watch this video. Oh god, that was a bad idea. We're not gonna make it big.
yeah, you got the square root of 4 minus x squared in the denominator. You could try use substitution, but it really doesn't simplify this in any reasonable way. How do you tackle this? And an insight that you might have is, well, this square root of 4 minus x squared, this looks like something that I might get if I'm dealing with the Pythagorean theorem, if I'm solving for non-hypotenuse sides of the Pythagorean theorem, especially if the length of the hypotenuse is 2, this would be 2 squared, and then the other side is x, then 2 squared minus x squared, this would be the length of the other side. Well, let's just run with that then. So if we have... oh
god, we have to draw triangles.
And if any of you didn't feel that insight immediately, it's okay.
Oh, you said I'm okay.
Because to be honest, I actually did not feel that insight probably the first time.
You did not feel it inside.
Like
bro, I don't feel anything inside when I look at trig.
So let's just visualize that insight that we talked about. So if the hypotenuse of the right triangle is of length 2, the hypotenuse is of length 2. The hypotenuse is of length 2. And let's say this side right over here. Actually, let me do this side. Let's say
this is how we get like the sine or cosine stuff out of it.
This side right over here is of length x. This side over here is of length x. It's a little counterintuitive because normally we associate this side over here with y, but let's just go with it. This side right over here is of length x. Then what would this side right over here be? What would this other non-hypotenuse length be? Well, just if you solve for it using the Pythagorean theorem, you get that it is going to be the square root of the hypotenuse squared, 2 squared, which is just 4,
a squared plus
minus
b squared
the other
equals c
side
squared,
squared. So minus x squared.
Love that.
Well, that's interesting. That is this expression, that insight, that intuition that we may have had when we saw this right over here. But still, how does that help us? Well, this is where the trigonometry comes in.
Oh, God.
Because if we define... if this angle right over here, we say this is theta, then what is sine and cosine of theta going to be in terms of these sides?
Sine is going to be
well, let's see. The
opposite
sine of
over
theta,
hypotenuse.
Sine of theta
x over
is
2.
equal to the opposite over the hypotenuse is equal to x over 2.
And then the cosine
if you want to solve for x, we get x is equal to 2 sine theta. Well, that's interesting.
Okay.
What about a cosine of theta? Cosine of theta is equal to the adjacent side, square root of 4 minus x squared
over 2
over the hypotenuse. Or if you want to solve for this side, it's going to be...
I swear this won't only be watching videos. Damie reacts to math
x
content.
squared is going to be equal to the hypotenuse times the cosine of theta.
Okay.
So that's interesting. If x is equal to 2 sine theta, then this other side, then this entire expression simplifies to 2 cosine theta. And that seems pretty interesting now. So let's make the substitution. Let's say that x is equal to 2 sine theta. And if x is equal to 2 sine theta, then dx is going to be equal to 2 cosine theta. D theta. And then if x is equal to 2 sine theta, then what is this thing right over here? Well, we just figured out this thing is 2 cosine theta. This thing is equal to 2. Let me do it in that orange color. 2 cosine theta. This is equal to 2 cosine theta. And we were able to do this, drawing this right triangle and using the SOHCAHTOA definition of these trig functions. And obviously,
that written down
circle, that's kind of an extension of these. But you could also do it if you say, hey, look, you know, if this is 2 sine theta, you could use the Pythagorean identity, our trigonometric identities, and you would see that this entire expression, if you did it that way, would simplify to 2 cosine theta. But now let's just run forward and let's see if we can evaluate it using this substitution. So this is going to be the indefinite integral. So dx, so 1 times dx, that's going to be dx is 2 cosine theta d theta. So let me write that. That is 2
You guys won't be able to see it, but just imagine.
Theta. I'll write the d theta out here. And then what's the denominator? Square root of 4 minus x squared? Well, that's 2 cosine theta again. So that is 2 cosine theta. Well, this seems to work out quite nicely. If you 2 cosine theta over 2 cosine theta, that's just going to be 1. This simplifies. This simplifies to d theta, which is, if you just evaluate this is just going to be equal to theta plus c. Well, this is kind of nice, but we're still not done. We want this. We want our indefinite integral in terms of
what? X is going to be.
So now let's just solve for x here. So if x is 2 cosine theta, if x is 2 sine theta, so x is equal to 2 sine.
Ew, that's gross.
X is equal to 2 sine
x
theta.
over 2.
Then let's see, divide both sides by 2. X over 2 is equal to sine theta. And then if you want to solve for theta, theta is the angle that if you take the sine of it, you get x over 2.
That's not fun.
So we could say, let's give ourselves a little bit more real estate.
You know what? I'm going to keep an open
that
mind.
Theta
Maybe
is equal to the inverse sine of this thing, x over 2. We could write it that way. Or we could write that theta is equal to the arc sine. The arc sine.
I'm not an arc sine enjoyer, but
the arc sine of x over 2. So this is going to be equal to the theta is arc sine of x over 2. So let's just do that. Arc sine of x over 2.
We should probably do
and we're done. We've just evaluated that indefinite integral. Now, some of you might have noticed something. I kind of brushed past it really fast just to give you the big, see the forest for the trees. But there's some interesting details that it's, I think, worth digging into a little bit over here. So the first one is, you might see that, look, the restriction on x here is, or the domain here on this expression is restricted. So let's just keep track of that to make sure that we didn't do anything strange when we did that substitution. So the domain here, x has to be greater than -2 and less than 2. If the absolute value of x were equal to 2, then you'd have a 0 in the denominator. If the absolute value of x is greater than 2, then you're going to have a negative in the denominator, and that's not defined. So this right over here is the domain. So let's say make sure that our substitution didn't do anything weird with that. So if x has to be between -2 and 2, and we're saying x is 2 sine theta, that means 2 sine theta would have to be between -2 and 2.
And it is.
So -2 would have to be less than 2 sine theta.
It's just a little restricted.
2 sine theta, which would have to be less than 2.
It just can't be
divide all the different parts of this compound inequality by 2, and you're going to get -1 is less than sine theta, is less than sine theta, which is less than 1.
Let me just remember what the actual one we're trying to
solve. The way we can do that is if theta is less than pi over 2, at pi over 2, sine of theta would be equal to 1. and if theta is greater than negative pi over 2. So if we restrict it in this way, if we say theta is going to be in this range right over here, then we are restricting our domain in a reasonable way. And this works out well because this typically is the range for the arc sine function. So we could feel good about that. Now another question that you might have is, okay, well look, we divided by cosine of...
Okay, let's try. Let's try a little something, chat. Let's do a little drawing. Yeah, I can draw. It's cool. Okay. So a student makes a substitution. This equals 3 cotangent of theta. So if this equals 3 cotangent of theta, that means that we're saying... So we're saying the... Be a little quiet for this. I'm gonna do a hint on this one. I'll do a hint. Okay. So since it's between 0 to pi over 2, we can use trig. Cool. So the 5x is the... So the first thing I'm guessing is going to be the hypotenuse then. And then the 3 is the... Oh, sorry. The 3 is the square root of 9. Yeah, I get it. Okay. Now, is it because cotangent is opposite over adjacent? No, adjacent over opposite. So that would be this over that. Okay, let's see. The sine of an acute angle of a right triangle is the opposite. Oh, okay, so that's normal. Okay, so we basically, it looks like we just have to draw a triangle. Okay. The cosine is the, right? So it's flipped. So this one is right and that one is right. No, it's not. I lied. Not that one. Second, third, and fourth. Wait, the second is right? Oh, yeah, here. Okay. Let's see if we can get it. I think I got it. I think I got it. Here we go. Let's try. No, wait. No, I have to use one? Oh, boy. Okay. So, okay, we have to draw a triangle. Whoa. Where our hypotenuse is going to be x, and so these are all tangents, but I don't think we want a tangent. Do we? Oh boy. So if we do this here, we're gonna have a 2 somewhere else. This is our theta. Oh boy. It does not like me using this. Where are we gonna put the 2? Okay, giving up. We're gonna watch another video.
We can evaluate this indefinite integral. And the clue that trig substitution might be appropriate is what we see right over here in the denominator.
He's so quiet.
In general, if you see something of the form a squared minus x squared, it tends to be a pretty good idea, not always, but it's a good clue that it might be a good idea to make the substitution x is equal to a sine theta, because if you do that, then this will become a squared minus a squared sine theta, and if you factor out the a squared, you can start leveraging, this is squared, you can leverage one of the most basic trig identities, that this right over here is cosine squared theta, and maybe simplify the expression.
Wait, I missed
In general,
that.
if you see something of the form a squared minus x squared, it tends to be a pretty good idea, not always, but it's a good clue that it might be a good idea to make the substitution x is equal to a sine theta, because if you do that, then this will become a squared minus a squared sine theta, and if you factor out the a squared, you can start leveraging, this is squared,
1 minus sine squared,
you can leverage one of the most basic trig identities, that this right over here is cosine squared theta, and maybe simplify the expression. Now you're probably saying, well, this 8 minus 2x squared it's not as obvious that it's a squared minus x squared, but we could simplify this, or I guess we can write it in a way that it starts to have this pattern. You can rewrite 8 minus 2, let me write it right under it. You could write 8 minus 2x squared as, if we factor out a 2, as 2 times 4 minus x squared. And now this very clearly has a pattern a squared minus x squared. You can write this as 2 times 2 squared minus x squared. So in this case, a would be equal to 2. So let's make that substitution. Let's make the substitution that x is going to be equal to 2
sine theta.
2 sine theta, and dx is going to be equal to 2 cosine theta d theta. So what's this part under the expression going to be? Well, we already started simplifying it right over here. It's going to become 2 times 2 squared minus x squared. X squared is 2 sine theta, so x squared is going to be 2 squared sine theta squared. And now we can factor out the 2 squared. So we're going to get, this is going to be 2 times 2 squared times 1 minus sine squared theta,
which is cos
2 times 2 squared, well, that's just going to be 8 times cosine squared squared theta. That's what we have under the radicals.
And then you can like integrate that.
Let's rewrite this thing up here. So we're going to have, I'll take the pi outside of the integration. So we're going to have pi times
oh wait,
dx.
never mind. You don't even need to do that. That's just
cosine theta d
like,
theta.
What is that?
So it's going to be 2 root
dx, 2 cos theta.
I'm going to do that in blue. dx right over there is 2 cosine theta d theta.
I forgot.
So 2 cosine theta, and I'll write the d theta out here. I could have written it in the numerator. And then here in the denominator, I'm going to get the square root of this business, the square root of 8 cosine squared theta. So the square root of that is going to be 2 square roots of 2. The square root of 8 is 2 square roots of 2. So let me write this. So let me make it clear what I'm doing. So this right over here is going to be the square root of this, which is 2 square roots of 2. That's the square root of 8. And the square root of cosine squared theta is going to be cosine theta. Cosine theta. Now you might be saying, hey, wait, if I take the square root of something squared, then wouldn't that just be the absolute value of cosine theta? In order to take away the absolute value, I would have to assume that cosine theta is positive. But we can make that assumption that cosine theta is positive, because if we look at this part, if we look right here at this part of our substitution, if we wanted to solve for theta, you divide both sides by 2 and you'd get x of 2 is equal to sine of theta, or we could say that theta is equal to arcsine of x over 2. Now the arcsine function, as it is traditionally defined, will return a theta that is between between negative pi over 2 and pi over 2. And in that range, cosine of theta is always going to be positive. So we don't have to write the absolute value. We know
he's doing big brain moves.
So now we can start to simplify.
But we're gonna just try and focus on doing the technique. I don't really want to care about the domains and stuff right now.
This 2 cancels out with this 2. We could bring this square root of 2 outside, and so we are left with pi over this square root of 2 over the square root of 2 times
d theta,
the indefinite integral of just d theta.
Which is just
and
theta
this is just
plus
going to be equal to pi over the square root of 2 times theta plus c. And we're almost done. We just have to rewrite this in terms of x. And we already know that theta is equal to arcsine of x over 2. So we can
so that's
say
not
that
too
pi,
awful once you
this
do that.
indefinite integral, or the antiderivative of this expression, is going to be pi over
Okay, so
the
once
square
you
root of
find
2
your x, then it does.
arc
You don't have to do
sine,
triangles. I don't
arc
think.
sine of x over 2 plus c.
Right?
And we're done. Some people don't like a square root of 2 in the denominator. If you want to remove it, you can multiply this by square root of 2 over 2.
We're gonna try
but
again,
square
and
root
we're
of
gonna
2
fail again.
over square root
But you know what? That's math, right? Okay. Wait, I don't know what it is to use that one.
Let's say I have the indef x derivative. I can find it from both sides. We get, or at least that's x that. Sine over square root of, we can't, so we could just write that dx is equal to square root of 3 over the square root of 2.
Wait, why are they doing
dx. I could have
the
just
same?
written
I want a
dx
different one.
So this thing right here
with tangent.
is let's see if we can evaluate the
Yes, 1 plus x squared. That's what we need anyway. So we have a minus x squared. So there's like 3 things you can do. You can have a squared minus x squared. You can have x squared minus a squared, and you can have x squared plus a squared. If you have x squared plus a squared, you have to use x equals a tan theta, I believe. And if you have x squared minus a squared, you have to use x equals secant, a secant theta, I think.
Integral, we should x is equal, try out x is equal to a tangent theta.
Yeah, a tangent theta.
Now, why is that? This right over here, we could reprove it. Actually, let me just reprove
secant
it for
squared.
you. This is going to become a squared times, this is 1
I don't like that one,
as
but
cosine
you know what?
squared theta
Sometimes we gotta
over
use it.
cosine squared theta, squared theta plus sine
Oh, he's really
squared
doing it out.
theta, which might simplify
There we go.
things. So let's see if we have what's going tangent differential form. Dx is equal to 3.
Cool. Okay, back to the board one more time. X squared minus 4, the only one they didn't tell us if you x squared minus something. So I think we're gonna do, here, I'll actually write it on here. So if we have x squared minus 4, we're gonna have x equals 2 secant, holy bajoli. Okay, we gotta write real slow, I guess. Secant. Okay, never mind, I lied. We're not writing real slow. This is just not capturing my pen input. Where's my mouse? There we go. Here we go. Let's rewrite this. Okay, so we have this is what we're working up to. Okay, this one. This one over here is going to be 2 to 4 x squared minus 4 3/2 dx. So we say x equals 2 secant theta. We're gonna get, well, dx equals 2. Oh, what the fuck is the derivative of secant theta? I think it's like secant tan. 2 secant. Oh my god. 2 secant squared tan. 2 secant. Wait. Yeah, sec tan. I was right. So it'll be 2 secant theta tan theta d theta. So we got that. Then if we substitute this in, we'll get 2 to 4. A lot of 2 initially. I lied. A lot of 4 initially. Secant squared theta minus 1. This is tan squared theta, but 2 to 3/2. So it'll be 4 tan cubed theta d, but then times 2 secant theta tan theta d theta. So it'll actually be okay, well this doesn't matter anymore because we've deleted the limits. We've mangled them. 8 times tan to the 4th secant theta d theta. Is that one of the answers? No, it's not. I'm gonna put none of the above, and it's gonna be wrong, but we're gonna see where we're wrong. No, what is it? What is it? What is it? Where did I mess up? Is it 16? It's gotta be 16, right? Oh, the limits are different. Oopsies. This one, I'm guessing. I'm guessing? Where did I miss a 16? X squared, that'll be 4. You pull out the 4. Never mind, it's 4 to the 3 halves you pull out. You can't just pull that out. Awesome. Yeah, 4 to the 3 halves is gonna be 8, and then... Cool. Okay. Okay, chat. We got this. We got this. Okay, which of the following equations is incorrect? Okay, x equals 2 cosine theta. So this is saying cosine theta is x over 2. That one's got to be wrong, right? Okay, what is sine theta? So sine is opposite over hypotenuse. B is correct, right? So that's the opposite divided by the hypotenuse. Cotangent of theta is the adjacent over the opposite. Adjacent over the opposite, perfect. Secant of theta is the hypotenuse over the adjacent. Have I considered doing sexist math? I don't know what that would be. How? All math is beautiful and loving. What? How is that one? What? What? How is that not right? What? Oh, it's 2 over 4. 3 plus 4 equals 3 plus 4. Oh my god, I can't read. 3 plus 2 equals I hate women. Yeah. Okay, why is that one right? Secant in my brain. Secant is 1 over cosine. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Oh, it's because that's flipped. That's like... Okay, we're going strong, chat. 0 for 0. Or 0 for 4. Okay. So we have 4 minus x. That's something minus x. That's gonna be... Wait, look at our charts. Let me sign, I believe. Yes, so x... Let me switch this over. If x equals... X is going to be equal to 2 sine theta. So if we plug this in, it'll be 1 over 4 sine squared theta square root 4 sine squared theta. Nope. 1 minus sine squared theta. Which will equal 1 over 4 sine squared theta times 2 cosine theta. Whoa, what? I have to evaluate this thing? Bro, that was not in the job description. Oh my god, it's gonna be... Is it gonna be... No, bro, no. Not the integration by parts, bro. Not the integration by parts of the shitty trig functions. Is there any other way? Is there any other way? Please, bro. Oh god. Am I missing something? I don't think so. Oh, I need to put in the dx. I need to put in the dx. Yes, I am missing something. Oh, thank god I put in the... Oh, thank... Big brain. Big brain. 2 cosine theta. Okay, this will cancel. Oh, that's so much better. Okay. Oh, I was getting scared there. Okay. This is still the integral of like 1/4. 1/4 1 over sine squared theta? Do I know how to power rule this on the bot? Wait. I'm thinking. I mean, I can do integration by parts with sine times sine. Wait, no, it's not sine times sine. It would be CSC. Do I know the derivative of this? Do I know? Like, oh, the song is so quiet. Turn it down so low. There we go. Do I know what the derivative of CSC is? I mean, I definitely don't. I think it's like CSC secant. I did a boot camp on this like a long, no, cotangent secant, negative cotangent secant, bro. I mean, can I even integrate this? What is the, I don't think this music too loud. Okay, Slay, I'll turn it down. Oh, I forgot. I should turn it down over here. There we go. How's that? Bro, my brain is melting. Why is this so hard? Why is this so hard? Okay, we're gonna use a hint. You know what? The big math major. I'm not a math major. I don't know why I said that. Dude, this is why I'm not a math major. Okay. Yes. Yes. Wait, they want me to use what? What? X equals 2 cos theta. What? Bro, what? Wait, what? Wait, I'm confused. Wait, what's happening? Wait, I'm confused. Should I not be solving this like this? Okay, since we have the expression this in the integrand, we let that equals that. Easy, did that. Okay, got one step down. You know what? Pats on the back for one step. You can also use right triangles. And sine of x equals that. Okay. Okay. That gives us... Oh, they want... Bro, okay, I see. 2 cos theta. Wait, never mind. They got to the same thing I did. Okay, they did like a... Wait, bro, they could have just integrated that. Okay, whatever. Doesn't really matter. Took the derivative, sorry. Substituting, yeah, okay. You get 1 over 4. Oh my god, wait. I'm evil. I'm evil. I'm literally evil. Oh my god, I can't believe I forgot the negative CSC squared. Dude, oh my god. Bro, that's like easy town. Oh my god. Oh my god. Anyway. Yeah, negative tangent. Negative 1/4 tangent. That's the derivative of tangent. Oh. No, it's cotangent. Sorry. Cotangent. Bro, I need to like catch up on my derivatives, not gonna lie. My trig derivatives, I have to go over them every single time. And then we just look at the right triangle. Okay. So I should be making right triangles probably last, I think. But then you can make the right triangle from the x substitution. Okay. Let's try again. Okay. That's the negative, this thing. I'm just gonna copy this, because I got 0 out of 0 anyway. It's fine. 0 out of 4. Awesome. 0 out of 4. Thanks, God Academy. No, don't put me on integration by parts. Bro, I know how to integrate by parts. Okay. Here we go, chat. Big brain. Okay, we've got something minus something else. That's gonna be secant. No, fuck. It's gonna be sine. Okay, it's gonna be sine. I lied. Okay, it's gonna be sine. Nice clean slate. We're gonna pretend the other stuff didn't happen. Okay. 16 minus x squared over x dx. You can't redeem? Wait, what can't you redeem? Wait, it's not Friday. I was gonna say, can't redeem on Friday? I mean, I turned some stuff off. Can you not redeem hydrate? I can redeem hydrate. Oh. There's hydrate and there's question. Fixed? Okay, select. Okay, so x equals 4 sine theta. If you have a squared minus x squared, it's sine. Okay. 4 sine theta dx equals 4 cos theta d theta. So this is 16. 1 minus sine squared theta square root over 4 sine theta times 4 cos theta d theta. Okay, that's the easy part. I like that that's the easy part because I used to not be able to do that, so we're making progress. This is going to be equal to the integral. This is going to be 4 cos, right? 4 cos squared theta over sine theta d theta. Yeah? Now, this is equal to 4 times tangent CSC, which is equal to, now is it a positive or is it a negative? I think that's 4 secant. No, it's not. I think that's CSC. And I think it's positive. I'm gonna go out on the limb, I'm gonna say that. So I think that's what it is. Now we have to like figure out what the hell anything is. We have to make a triangle now, I guess? Which is like theta. Okay, x equals 4 sine theta. So the sine is opposite over hypotenuse. Opposite over hypotenuse. And CSC of theta. Can you do something easier? Yeah, sure, I can do something easier. What do you want to do? This is not the Wild OST. I've been so bad at we can do something easier. You want to do 1 plus 1? No. Give me something, I'll do it. We can do trig integrals. It's not much easier, but trig sub substitution. Okay, CSC is like 1 over sine, right? Do 52 divided by 6. $26 over 3. That's not real. Am I tripping? Wait a second. Yeah, 6 is not going to 40. There you go. 52 divided by 6. 26 over 3. Which, like, okay, we can, 24 is 8. That's like 8. That's 8 and like 2/3. $52 divided by 6. 6 doesn't go into 40. Oh, you want to do division? Long division? Like this? It doesn't work for this. 6 doesn't go into 5. So you just have to go with the whole number. It's not worth it. I just divided both by 2. It's 8.66666666. Yes, it does, surely. Well, like, think about it this way. 6 times 10 equals 60. 6 times 9 equals 54. 52 is in between these two. No dice. What a great little... Okay, wait, sine is opposite over hypotenuse. So we need hypotenuse over opposite. 4 over x? Bro, that's not right. Oh shit, they didn't ask me to evaluate more. Wait, let's try. Let's see if we get one right, chat. If I get this right, I'm gonna be so happy. I said x equals 4, CSC. Wait, no, if x equals 4 sine. Bro, they didn't even give the hard part. I mean, I got it, but that's not even like fun. Damn it. Okay, fine. Okay, this is just a triangle problem. It technically didn't even finish this. Well, CSC is just 4 over x. This is gonna equal like 16 over x. What the hell is that? That's not right. Wait, let's see what the cosecant derivative is. And no, it's cotangent. What is tan times CSC? Oh. Is it nothing? No, it's secant. Wait, is it secant? Wait. Wait, it's cotangent. Wait, what was I doing? Wait, cos squared over sine? Oh, bro, it's cotangent, cosecant. I was right though. Cotangent, cosecant. Except it would have been negative. Okay, that was good. That was good. That was good. That was good. It's good that I saw that though. Okay, we gotta do another triangle. Everybody tired of triangle? Figure out my credit card number using math? Well, if we talk about the Bernoulli distribution, or whatever it's called, there is systematically the highest percentage of ones occurring in a random number, that then goes down over time until it hits a limit. Well, 10 cannot be a card digit, but you know what I mean. So, statistically, the most likely number to be your card number is 111, 111, 111, 1111. Big brain. Statistically. Figure it out using math? Okay, let me just get out my math ball. Let me look in there real quick. I'm looking really hard. It's telling me the secrets. Oh, your secrets are so exciting. I see a card. And I see numbers on it. Divining the numbers. The numbers are so strange. They're revealing themselves to me. Wow. That's so awesome. It's beautiful. It's what math can do. This is the math ball. Save this? Yeah, I'm not gonna delete it. It's fine. Here, there you go. I'm baby? Yeah, I am kind of baby. I like drawing Damie. My favorite way to draw Damie is like... I used to draw him like... I draw like this a lot in my math notes. Big glasses. And this is what I do instead of paying attention in lecture. No, I'm kidding. I pay attention in lecture. But yeah, sometimes you just need to sopping wet guy. So true. He's literally like wet. I love drawing him. He's literally so, this is actually me in math class trying to understand sometimes. I'm like, bro, what? I especially like drawing, my professors are gonna see him a lot on tests. Because I'll write something like if it was something like this, I'd be like, what the hell is this? Like, bro, what the heck is this? Don't give me the secant derivative. Yeah, that's my they're gonna know. Yeah, my professors watch my streams actually. They're like, no way, you're Damie VTuber? It's Raymond? This is just like eyebrows and, well, normally I'll draw something. Like this. And then I'll write some Twitch lingo that they could never possibly know. Or something like, I spent 20 minutes on this. Just copium. This is what I do. My old professors used to like it. I should work with you? Like in real life? Oh, on a project? Yeah, sure. I'd love to. Like a robotics project, or like just like a silly project, or like, hello Vintage Luigi, that is the coolest name ever. How's it going? We're doing TRIG substitution. A VTuber project, yeah, I'd do that. We are molding over TRIG sub right now. Well, I'm molding over TRIG sub, it's fine. I'm so normal about it. I hate having to remember derivatives, it's fine though. Okay, so if x equals cosine 4 cosine theta. Then like, you know, x over 4 equals cos theta. Trig needs 50 followers to get affiliate and accept sub? Is that just like Trig, like in general? I'm so confused. You know, my brain is kind of melting after all this Trig. Like Trig itself? Like the math of Trig? Oh, bro, the Trig sub. No, that's actually so true. That's so funny. I did contemplate writing like something in the title that just said like, we're doing TRIG subs, and then I was like, I don't want Twitch to like think that there's any dom sub happening. just the concept of a trigonometry sub is funny to me. Like yeah, you know, I'm submissive, but like I really like trig, bro. Like I really like trig. Like what are you gonna do? Like really be into triangles during? That was a good joke. Okay, cosine adjacent over hypotenuse. And then this one is the like 16. Oh wait, I forgot what it was. Doppelganger. I hate pre-calc. Yeah, kind of based. Trig is like trig is rough. When am I going to post pics on my air freshener? I don't. What? What? Oh, it's okay. I also can't spell. My air freshener. Well, this would be 4, like 16 minus x squared. Okay, let's see. Which one of these are right? Okay, let me turn off this. Okay, so we've got theta equals, yep, that one's right. That something equals 4 sine theta. Yes, that one's right. CSC, which is 1 over sine theta, is going to be the opposite. CSC would be hypotenuse over, yeah, that one's right. And then cotangent, which is going to be, wait, cotangent is going to be, adjacent over opposite. Wait, okay. Brain not work. These are not all right. What if they're all right? Okay, let's try it. Let's go, chat. Oh, sorry, I was clapping right in front of my face. Breaks my tracking. Okay. Okay, we have x squared minus something. That's gonna be secant. Secant. Am I right? Wait. Secant, secant. Let's go, it's secant. I'm learning. Why is the derivative of sine squared x equal to the derivative of negative cos squared x? I love the chat face. I mean, I could prove it. But like, you can't just, you can't just do like derivative sine. You gotta like do the power rule, right? So like that would be 1 minus cos 2x, or 2 over 2. Is it plus or minus? I forget, whatever. And it's like negative. Actually, wait, yeah, the way I can tell you it is that like one of these is plus and one of these is minus. So when you do the power rule for like cos squared and sine squared, and you turn them into like this, it's either like plus or minus cos 2x. That's why. That's one of the reasons why. In the easiest way I can put it. I like this drawing a lot. This is good drawing right here. Anyway. Let's do another problem. Let's see. What was I doing? Already forgot? Oh, we should probably go and try the problem that I was supposed to be doing. Alternative reason. Sine squared x equals 1 minus cos squared x. 2 differ by a constant? So true. Why is this sine... okay, I'll risk it. Why is this sine 20x above the negative cos 30? Reading that, I had a stroke. X squared minus 4 over x dx. Okay, so x is going to equal 2 secant squared. 2 secant. Which means that dx is going to equal a big headache for me because I already forgot this. This is 2. Fuck it. God damn it. It is secant tan. Okay, I know that one. God damn it. I was so close. Why did I write 2? It's just theta. Can you do Among Us math? Can you draw pictures so I understand? Yeah, here's the Among Us. What is my stream schedule? Well, I think I might be streaming tomorrow. But normally I stream on Tuesdays and Thursdays, and then on the weekend. And I stream math, I do physics, I do engineering, I do sometimes games that are like math and stuff. Sometimes I'll do Minecraft with like coding robots. Umbra, basically, this is like when the imposter opens his mouth and sticks his tongue out and eats somebody, and then they die. That's basically what this is. Here, I need to add this part. Yeah, that's what this problem is like. Do I usually do calculus or all math? So for my physics, like there's more algebra, I would say, or like more of a range, but I do calculus normally, and then I'll be doing like multivariable later this year and differential maybe. I, a rat, am cheesed. But yeah, I actually have done all this before. So if you were previously at my streams, you would have seen me doing, not this specifically because this was actually not covered, but last year I did a lot of similar stuff. But yeah, math, physics, that kind of stuff. And sometimes I do, oh, you have a puzzle. Yes, of course. Sometimes I'll do lecture streams as well, like my own lectures that I wrote, but most of the time I'll be doing stuff like this because, you know, I have work to do. Okay, let's just real quick do this one, and then we'll go back to the actual original problem, which is an arc length problem that just happened to use this. Okay. Okay. 4 times secant squared minus 1 tangent over 2 secant theta times tan theta, tan theta. Get rid of this, get rid of this. Then we've got tan squared theta. Now, for tan squared theta, 2 tan squared theta, but that doesn't really matter. Is that cotangent? I feel kind of dumb and small. I feel like a kid. Want to see shoes? Wait, why do you feel dumb? I just struggled with this for like an hour. Don't worry. I've just want to see shoes. Here, I'll draw a shoe. Oh, shapes. Oh, you want to see the shape? Oh, I can draw a shape. Like our triangle. So yeah, we have, if our x is 2 secant theta, right, if this is our theta, so x over 2 equals secant theta, right? And secant theta, we know this is 1 over cos theta. And we know that cos is so ka toa. So that means that this one is seca, I guess, like mecha. So it's gonna be hypotenuse over. So this is our hypotenuse. This is our adjacent, and then this side will be this thing right here. Because, you know, 2 squared plus this is going to equal x squared. So x squared minus 4. Look at that. So once we finish this, I need to make sure that this is right. Let's just check. Scroll all the way up. Yeah, that's secant. Because secant squared minus 1 equals tangent squared. Will give us tan. The derivative of secant is yeah, I'm just wondering. I mean, I know this, you can split this into like, you know, sine squared over cos squared, but that seems like kind of a lot to do. Because then we could power rule it to be like 1 plus cos squared over 2 over 1 minus cos squared. I don't remember if that's the right way or not, but then you have to like do that, and that's just like a really bad thing. Or we can do this. We can say tan of theta equals, right from our triangle, tan of theta equals opposite over adjacent equals opposite over adjacent. So wait, that just puts us back where we... It just put us back where we were, but... Oh, wait, maybe that actually works better. Let's just, like, try it. Why not, right? So 2... this would be x squared, or we can... Oops. We can pull the 4 out. And we get x squared minus 4. Oh wait, that's kind of cute. 1/2 x cubed over 3 minus 4x. Huh? Is that right? Bro, wait, they didn't ask me for all that. Oh god, that's so cringe. It's 2 tan squared, bro. Oh, let's see if that's right anyway. 2 tan squared. I keep doing the problems way too long. Yeah, 2 tan squared. Come on, be right. Let's go, Chad. Let's go. Let's go. Okay, now we're ready for the big leagues, okay? This was big leagues, but this is bigger leagues. It's graphical. Draw a grid of squares of size 2 by 3, but erase the corners of all the squares. Let's see, draw a grid of 2 by 3. Okay, 2 by 3. Erase the corners of all the squares? I assume that these are just like this, right? Like that? I don't know if that's... Sometimes I think I have a brain disease because I'm very stupid and regressing. It's okay. You know, if you don't use stuff, like honestly, right, I haven't used trig integrals and derivatives in kind of a long time. And it's okay. You know, you don't have to, like, learning this stuff is not necessarily important. In the same way that, like, yeah, in programming, if you're using like a for loop all the time, it's like, it makes it faster for you to not have to Google it, but if you need to like remember something, then it's not like a bad thing. Humans aren't like hardwired to be like, you know, like remembering machines. Like, yeah, we have good memory, but if you can't remember something, it's not the end of the world. Okay. We're gonna go from, we're gonna not worry about the integral, the limits here. We're gonna do 1 plus t squared. So we know that this has to be tangent. We learned, we adapted. So t equals tangent, right? And there's a 1 here, so that's nice. Wait, was that the whole problem, Luigi? Was it just erase all these? Oh, here we go. Ooh, okay. Take away 5 toothpicks and leave 3 squares with no extra toothpicks left over. And leave 3 squares? So the first 5 you could do is this, right? That leaves 4. Ooh, that's hard, isn't it? That's automatically not going to work. Ooh. I think I have to get rid of these in the middle somehow. No, not those. Wait, that was only 4. Wait, maybe that... No, that's not going to work. That already got rid of this 3 squares. There's a cool logical way to think about it. Makes it simpler. Ooh, exciting. It reminds me of, my math teacher used to give us brain teasers before class. I was not good at those brain teasers. I was not, let's say the best kid at those brain tools. Can you just get rid of these? No, that would make one big square. So it takes 2 to get rid of this. It takes 1. It basically takes 2 to get rid of every square. Except there's got to be one where it takes only 1. It needs to get rid of 3. 1, 3. Wait, oh wait. 1, 2, 3, 4. Five? Oh, this is so hard. 1, 2, 3, 4, 5? No. Puzzle 2, take away 3 sticks and leave 4 squares. Where do I do that? There's got to be a little tricky in here somewhere. I'm doing the same thing, but in different locations. I need to try different things. Like 1, 2, 3. Does that count as a square? Does this rectangle count as a square? No, I'm guessing not. Okay, wait, let me attempt to do this other thing first, real quick. No, I will come back to it, I swear. Okay, so 1 plus, this will be secant squared. Yeah, 1 by 1 square. So if we have t and then we have dt equals, right? Tangent is gonna be sectan. Right, sectan? Nope, secant squared. I am very smart. So we have secant cubed d theta. Oh god. Hi, Umbra. Bro, how do I get rid of this thing? How do I do that? I could power rule it. That sucks. How do I... Okay, there's a stupid trick to remember this too. I hate mathematicians. Hi, Clem. How's it going? I like how I redeemed Hydrate 32 minutes ago. Oh my gosh, I just realized since I'm not streaming on Fridays, I won't have Drown Him Friday. What is that emote? What is that? I forget that real people stream their faces on Twitch sometimes. I'm so used to being a catboy. Well, I am a catboy in real life. How to integrate like sine you just DC'd and splap a 5 win streak, bro. Oh my god, that's awesome. How to integrate secant cubed. Just gonna Google it. Oh, okay, I was right. God damn it. God damn it. Okay, it's actually not that bad. Wait. Wait, what? No, right, guys, I think Team Grub is gonna win. I want to play the Splatfest so bad. I want to play it so bad, but I can't. Also, Luigi, it's very funny. I might need to rename the storm problems because we have something in this chat named after a beautiful person named Storm who came into my chat and gave me problems to do every stream that were very hard, but that he liked. So if you're interested, I should probably make a redeem for that actually. But that is totally welcome. If you want to give me problems, I will do them halfway and then I will give up on them. But I won't mention it because I feel too bad about giving up on them. But if you want me to, Luigi problem, truth big square. But if you want me to do them, if you want to give me hints, if I stop working on it for too long, there's 2 reasons. I probably don't know how to do it. And B, I do actually have things. I'll really like the solution for the toothpick problem. Okay, you gotta give me a little bit of a hint. You gotta give me a little bit of a hint here. I love how all math majors are the same. Oh, are you? By the way, are you math major? What's your reason for showing up? You like math? You just randomly came in here and we're like, oh yeah, this is good, cat boy. I'll give him a toothpick problem. Okay. Big yawn. Sorry. Here, I'll move it. I think all the hints would be too much. Sigh. I suddenly discovered I like math today. Yo, that's awesome. You know what? That's awesome that you discovered it and you remember when you discovered it. I don't remember the day that I started liking math. It was somewhere in there. Once I started streaming it, I think. Okay. Do I like remove stuff from the middle? That makes it, no, you said 1 by 1 square. Okay, let's methodically go through. If I erase this, let's just like number them, okay? Let's say that this is like, this is 1, 2, 3, 4, 5, etc. So if we do 1, 2, 3, 4, 5, that leaves us with 4. If we do 2, 3, 4, 5, 6, that leaves us with nothing. About 3, 4, 5, 6, 7, 8. Again, nothing. About 4, 5, 6, 7, 8, 9. But you also said if you remove 3 and are left with only 4 boxes, how is that possible? And I can't like move the sticks around? Or will my engineering brain be like, how? A 1 by 1, nope. My engineering brain be like, can I move? Can I just use the sticks? Okay, let me put on some music. I'll put on splat music. It's gonna be like intense, but it's fine. That's 4. Put on CBAT? I might get copyright strike for CBAT. Just like imagine it playing in your head. I was walking, where was it? Oh no, I was like waiting for my first math lecture and I was like trying to find the buildings and stuff. And I finally found the building. I was waiting there. It was raining so hard. And I just hear CBAT from like up on the next floor. Just someone just really faintly playing it. Think about how many sticks you have after you take the ones away. Oh! Okay, so I have... Wait, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11... Wait, I'm bad at counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, distant CBAT. Okay, 17 minus 4, right? No, 5 equals 12. So, like, you need to make, like, 3 by 4. Each thing needs to be made up of 3, right? How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wait, what was I trying to make? How many was I trying to leave? No, 3. Yeah, so each one needs to use 4. Oh! 1, 2, 3. I did it! Oh my gosh! Wait, that was big brain. That was a really good hint, actually. So that's one of them. That's puzzle 2, right? And then if I take 5 away, I'm supposed to leave only 3? I did like the opposite thing. Okay, so if I take 5 away, 3 boxes. That means each box needs to have 4 sticks to make it up. Right? No. Each box needs to have 3 sticks to make it up. Wait. Oh, wait. If I take away 5... Each box needs to have 4 sticks to make it up. Thank you, thank you, thank you. So, like... Hey, that's 3. That's 3 somethings. That's 3 somethings. Yeah, that's not it though. What else? What else? What else could it possibly be? How else could I possibly do this? This is reminding me so much of math class, by the way. This is so funny. Literally exactly what my math teacher just makes do. It'd be like, here's a pyramid of things like this. How do you like light up these balls to like make something? And then I would go, oh, I don't know how to do it. And then some smart kid would solve it in like 5 seconds, and I'd be like, wow. I like brain teasers a lot. I, on the other hand, I'm pretty good at like problem solving, but like less so brain teasing. Just like a little bit about me. Wow. Okay. But I will think. I will big brain. We have 4 boxes, each made of 3. You have 4 sides each. What does that tell you about overlapping? That means that they need to share them. I just punched you guys. That means that every single box needs to share a side with another box. I still like this. I think that that's elegant. Whoa! Was that it? Was that it? Did I get it? Did I do it? Wait, it's not 4 boxes, it's 3 boxes? Oh my gosh. Okay, that's crazy. Oh wow. Okay. That was way bigger brain than like... Oh my god. Oh, that hurts. It's like when you're working on a math problem for too long, you know, and it's like, oh, it's good though. Thank you. That was beautiful. Okay, what we can do is this. I forget the exact way we do this, but basically you can say like secant squared. There's like a thing you can do. How do I do this? Is it integrating by parts? Oh, it's just integration by parts. Omega lol. Okay. Everybody ready for some IBP? Everybody's favorite thing. Do I remember how to integrate by parts? Yeah, I do. What am I talking about? I literally did this accidentally yesterday. Okay, so we'll just call our f secant squared. That's a bad idea. We're gonna call our f secant. I'll have my favorite thing ever. Alright, g is gonna be secant squared because you know we are going to get tangent out of this. Love it. His problem is so yeah, slay girly pop queen. I would love to say that in my math class, but like I feel like my professor would be like I really like my professor. He's very funny, though. He does this thing where he'll say something, so he'll be like, And so that is why he has this like, he has like a radio announcer voice also. He's like, so that is why this point on the cycloid, if you draw the tangent to the top of the circle, that's why that actually is the tangent crosses the top of the circle. And then he goes, he just inhales really loudly. I don't know if he does it because he like emphasizes stuff with it. He's really funny though. Am I an engineering major? Yes, I'm a mechanical engineering major. he just does it. I'm like, bro, I can't tell if he's just like like he's under the weather. He does have a very nice voice though. Like very calming. Like I aspire to that voice. My secant derivative is secant tangent. So now we just pair these up. It's like U, DV, U, practical. I like my pure math. I get so many pure math majors in my chat, bro. I got 0 engineering majors, except for Umbra. Umbra's robotics. Umbra's done with school though. I am just starting school. I basically have a class. Let me tell you about this. It's called ME 163. How do I explain this class? My professor came into lecture. POV, you're me in class. 2 giant screens. Pulls out a children's book. Reads to us the entire children's book. Puts the pictures on the slides of the children's book. It has a dragon in it, by the way. And then says, don't, like, basically, you can be an engineer, don't give up. This is a 2-hour lecture once a week. It's gonna be rough. It's gonna be rough, guys. It was pretty funny, though. So that's one of my classes. Seems unhinged. Yeah. I haven't even, oh my god, I haven't even, another one of my professors, so I have a welding class, like I have to take welding. Another one of my professors comes in, talks to us for like 2 hours about how people have gotten horribly injured in his class. And it's like, oh yeah, don't worry, it'll be fine. He told us about this guy whose pants caught on fire twice. Many awful things that probably break Twitch TOS if I said them on stream. People getting their fingers squished in things is the least bad. He's really funny though. He came into, so it's a lab and a lecture. That was the lab part. So like, it was this theater, right? Where like we were all sitting in chairs. These are like the chairs. There's like a screen here and like a screen here. So you, like the people in the back can like see it. I was sitting like here. He comes in. He's literally just scooters into the building. This is just a theater. He's just scooters into it on his like whole ass scooter. Just right down to the front. There's like a door back here. He just goes in the door. He comes back out. It's like, hey guys. There's another guy who just scooters into our math class. Like the hallways are really small. Like the hallways like this, and there's like doors, and this guy just scooters down the hallway. It's like an electric scooter. It's like 15 miles an hour, just inside. Like not a slow scooter, it's like a fast scooter. Yeah. The most normal computer science majors, I guess. I need to do this problem. Okay, this is not working. Where's my IVP? Wait, this is deriving by parts. I lied. Is that right actually? Wait, integration. Integrate. Yeah, wait, no, integrate by parts table method. That's right. It's so, that's just normal here. So, you can see me looking up this stuff. Oh, maybe I need to go again? What's the derivative of tan? That's secant squared. I kind of love my class though. They're kind of funny. This is sec tan minus. Wait, that's gonna just give me the same thing. What's up? Why is this doing this? Tan minus. Minus v du. Yeah, u dv is dv minus v secant squared. Wait, but that's gonna give me secant squared. No, this is v. Okay, I don't know. That's like close enough. I think. Wait, it's cos h squared? Secant cubed is cos h... what? I didn't know that. And then you just like integrate this. Wait, let me just show you this picture I'm looking at. Let me be real, I'm just looking at a picture. Okay, we can analyze. So you break it down to secant times secant squared. I remember that. I do integration by parts, which is u dv minus integral of v du. But that's not it. Oh. u dv minus integral of... wait. And then you have secant tan, and then you have to do that. Oh, I forgot about that. Wait, what? Wait, that's circular. Hello? Wait, is that not the integral of secant cubed again? Okay, maybe this is like... okay. That seems not correct. Whoa, why did they just immediately go to ln? What the heck is that one? I don't know what that is. I don't know what's happening. What? Gamers, what's happening? What is this? Oh. You know what? I think we're gonna call it. I think we're gonna call it here. I think I need to like make sure that this is not lying to me, because I don't see how the hell you're supposed to get an actual thing out of this. I will be like back with more physics tomorrow though. And like probably earlier, probably like at like 12 my time or something. So we'll call it here. We did some toothpicks. That was fun. Did some toothpicks to some. You know what? I'm better at trig substitution though, so that, you know what? I'm gonna call it a win, a dub. And I will see you guys next time. Hope you had a good time. Hope you have a good day. I'm gonna go sleep because I'm tired. Okay, see you guys tomorrow. Wait, where's my mouse? There it is. Okay, bye!